Hello everyone, today our topic is kinematics part 2. In this lecture we will learn about vector product. See what is a vector product. Let us say we have two vectors in a plane. Let us say this is your xy plane and this is your a vector and this is your b vector, and angle between these two vectors is theta. So our a cross b is defined as mod A mod B sin theta into n cap, where n cap represents the direction of A cross B. How to determine the direction of A cross B? By two methods we can find out the direction of A cross B, that is the vector product. One is right hand screw rule and another is right hand thumb rule. So in maximum number of cases we will apply this second rule, which is right hand thumb rule. See, this is your A vector. So from A to B you have to curl your finger, from A to B you have to curl your finger, then the thumb will represent the direction. See, I am from A to B, that's why the direction of angle is from A to B. You see the direction from A to B, you have to curl your finger, then the thumb will direct in the direction of vector product, which is A cross B. Otherwise you can use right hand thumb screw rule also. So if you rotate a screw, the direction of propagation of the screw, see, from A to B, from A to B you have to rotate the screw, then the direction of propagation of the screw will represent the vector direction of A cross B. Now if this is the direction of A cross B, then B cross A is in the opposite direction. So in B cross A you have to curl your fingers from B to A, then the direction is inwards. So here we can say that A cross B, is actually your minus B cross A, because the magnitude is same, but the direction is in opposite direction. So that's why A cross B equals to minus A cross B cross A. Now what is the geometrical interpretation of vector product? Geometrical interpretation is nothing but it's the area between A and B. It's the area of the parallelogram formed by A and B. Area formed by A and B. So A cross B, that is the magnitude of A cross B, magnitude of the vector product represents the area of the parallelogram. If you join Q and P, so here you can see that area of the parallelogram is twice the area of the triangle. This triangle and this triangle. Twice the area of the triangle. Now example of vector product, that is, see, torque. Torque is R cross F. Angular momentum, which is R cross P. It is P is your linear momentum and L is your angular momentum, and instantaneous velocity we learn it in circular motion, V equals to omega cross R. All of them are cross product and all of them are the example of vector product in this section. So we can move forward in our next topic, which is properties of vector product. See, if there is two vectors, that is A vector and B vector, and we can apply here the right hand thumb rule from A to B, we can see that the finger is the thumb is coming outward. That means this A cross B is perpendicular to both A and B. And if you move from B to A, and then apply right hand thumb rule, then the B cross C is inward. So we can say that these two magnitude wise A cross B and B cross A are same, but the direction is opposite. So A cross B equals to minus B cross A, that is they are anti-commutative. Now we can apply distributive property in a cross product also, vector product. A cross B plus C is A cross B into A cross C. Now see, if two vectors are parallel or anti-parallel. Anti-parallel means 180 degree, parallel means 0 degree. So AB sin 0 or sin 180. Sin 0 is 0, we know, but sin 180 is sin pi. We know sin n pi is equal to 0. So if it is sin 0 or sin 180 degree, then it would be 0. This property we will use vigorously in problem sums, where it is given that if if it is given that two vectors are parallel or anti-parallel, then we will obviously apply this formula, that's A cross B equals to 0. Next, if we find out the vector product with itself, that means any vector is parallel to itself, that means the angle is 0, that means A into A sine 0, that means 0. So A cross A is 0, B cross B is 0, anything. Now if we find out the magnitude of A cross B for two mutually perpendicular, if two vectors are mutually perpendicular, let us say in this case A and B vectors are mutually perpendicular, that means 90 degree. So sin 91 we will get the maximum magnitude in perpendicular vectors. Now vector product of orthogonal unit vectors. See, in the orthogonal unit vectors, that means these three unit vectors for I, J, K, that let us say this is x axis, this is y, z axis, this is I cap, this is your j cap, this is your k cap. X, y, z are perpendicular to each other, that means unit vector representing x, y, z are also perpendicular to each other. Then if we want to find out the cross product between I, j and k, we will apply this revolving method. That is, if we move from I to j and if we get k, then we will take positive sign. Let us say we are finding out I cross j, so we are moving from I to j and we are getting simply k, so that means plus k cap. If we moving from k to j, let us say we are moving from k to j, that means we are moving against the clockwise direction. So for anti-clockwise direction, k cross j, so you will get I, but this is minus I because we are moving in the anti-clockwise direction. For clockwise direction you will get positive, for anti-clockwise direction you will get negative. Find out anything. Let us say we are finding out k cross I, so that means we are moving clockwise, so k cross I would be plus j cap. If we find out j cross I, that means we are moving anti-clockwise, so we will get minus k. This is as simple as that. Always remember, if we find out the cross product between the same unit vectors, that is I cross I, j cross j and k cross k, that means this is the case of parallel vectors. Any vector is parallel to itself, that means we will get 0 because we have already proved it out. A cross A is 0, that means I cross A 0, J cross J 0, K cross J 0. So that means similar cross product is 0 here. And in the vector dot product, we know I dot I, j dot j and k dot k is 1, but for vector cross product, I cross I, j cross j and k cross k is 0. We can directly find out A cross B if two vectors are given in this format. A is ax I cap, ay j cap, az k cap, b is this. So we can find out from determinant method, that is write down first ijk, then the magnitude of ijk of a vector, because we are finding out A cross B. If we want to find out B cross A, then first write down bx by bz here in place of ax ay az, then bx by bz. Okay, in this method we can find out A cross B directly from determinant method. Now if we want to find out the sign of the angle between two vectors, then sin theta from here, see, we know that A cross B is equals to AB sin theta if we ignore the unit vector here, so sin theta would be A cross B, mod of A cross B. We are finding out the magnitude, that's why mod of n vector, any magnitude of unit vector we know that it is 1. So mod of A cross B divided by AB, that should be equals to sin theta, so this is your sign of the angle between two vectors. Now if we want to find out the unit vector, so it is as simple as that. A cross B, we know this as AB sin theta into n cap. So what would be the n cap? N cap would be A cross B by AB sin theta, and if we are finding out the magnitude, then unit vector would be A cross B by mod of A cross B. What is AB sin theta? This is magnitude, right? So this would be A cross B by mod of A cross B. This formula is extremely important if they are asking for unit vectors which is perpendicular to plane of the two vectors. We already know that this unit vector is always perpendicular to both of the vectors. So if any information is given in the question, then we will directly apply this method, vector method, to find out the unit vector along perpendicular to both A and B. Everything right? Okay, let's see three types of problem from vector cross product, or it is simply known as vector product. The first question is, determine a unit vector perpendicular to both this vector 2 I cap plus j cap plus k cap, and B vector is given as I cap minus j cap plus 2 k cap. In the property section, we have already written down this formula for unit vector, that is A cross B by mod of A cross B. Now I have also mentioned that if we want to find out A cross B, either we can go by this method, rotation method, by this rotation method, or from this determinant method. So determinant method is much easier than this rotation method, because here there is a chance for a mistake. Now let us see how to solve this determinant method. Always remember that the sign of the first row is always plus, minus and plus. Now this thing, that is the for I thing, for I the minor is this thing. If you want to take I, then delete this I, the row containing this I and the column containing this I. Then you can see that 1 1 minus 1 is a new determinant, and this determinant is known as the minor of this I vector. Now next sign is our minus. So minus of what is this? J, minus of j. Now we have to find out the minor. So j, delete the j column and delete the j row. So you will see 2 1 and 2 are the minors, determinant of that thing. Now next thing is k, so plus k, then write down plus k and delete the column related to k, delete the row related to k. You will get 2 1 1 minus 1, 2 1 1 minus 1. After that, what you have to do, that this I multiplied by this 1 multiplied by 2 minus 1 into 1. So that means 1 into 2 is 2, minus of 1 minus 1, that is plus 1. Here again simple logic, 2 into 2 minus of 1 into 1. Here 1 into 1 minus of 2 into minus 1. Sorry, 2 into minus 1 minus of, always come from upper then lower. 2 into minus 1, then 1 into minus of 1 into 1. You will get something like this. Now simplify, you will get this vector. So we got this n cap. Now we have to determine the unit vector perpendicular to both this vector and this vector. So find out the magnitude of A cross B. Magnitude is root under of A square plus B square plus C square. A is 3, B is minus 3, C is minus 3. So root under of A square plus B square plus C square. Simplify this, you will get 3 root 3. Now what is n cap? We know A cross B by mod of A cross B. We got mod of A cross B 3 root 3, and we got A cross B as this vector. So this vector divided by A cross B, which is 3 cross 3, we will get the answer. Because we know in A cross B, if there is two vectors A and B, A cross B is a vector which is perpendicular to both the vectors, perpendicular to both A and B. So that's why it is given, determine a unit vector perpendicular to both A and B. Perpendicular to both A and B is a cross product vector A cross B, as we know from our basic knowledge of vector cross product. Now come to the second question. For any two vectors A and B, prove that this thing A cross B whole square is equals to A square into B square minus A dot B whole square. Now see, A cross B whole square and determinant of mod of A cross B whole square are the same thing. So mod of A cross B whole square, mod of A cross B. A cross B we know as mod A mod B sin theta. So AB sin theta. In place of A cross B we can write AB sin theta. Now AB, A square B square, remove this from the square term, and sin square theta we can write it as 1 minus cos square theta. then break down a square b square, then it would be a square b square minus a square b square cos theta, then we can write it as a b cos theta whole square. Now what is mod a mod b cos theta? That is a dot b. So we have already proved this. Now come to the question number 3. Find a vector whose length is 7 and which is perpendicular to each of the vectors. See, here the same logic is here. You have to find a vector which is perpendicular to both the vectors a and b, perpendicular to both the vectors a and b, and whose length is given as 7. So how do we represent a vector? How do we represent a vector? We represent a vector by its magnitude, some magnitude, multiplied by its direction vector, its direction. So magnitude is given as 7, magnitude is given as 7. We just have to find out this unit vector which is perpendicular to a and b, and we already know from vector cross product that any perpendicular vector which is perpendicular to both a and b is actually your a cross b, is actually your a cross b. So we have to find out a cross b. Again the same logic, you have to break this determinant. So apply this method, the same method, apply this method here, you will get the vector as this thing. Now second thing is mod of a cross b. Mod of a cross b is root under of a square plus b square plus c square, you will get 7 root 2. Now what is n cap? A cross b by mod of a cross b. You got a cross b as this thing, and mod of a cross b is 7 root 2. So divide and you will get n cap, but you have to find out a vector whose length is 7, and which is perpendicular to each of the vectors a and b. So perpendicular vector we got as n cap, perpendicular vectors to both a and b we got as n cap. So 7 magnitude multiplied by direction. So direction is this vector, divide, cancel out 7, you will get the vector which is your required vector. So we are moving forward to our next topic, which is motion in a plane. Let us say we have a position vector, let us say p, x comma y is our position of the particle in a particular moment. So see, in x axis our direction vector is I cap, so magnitude is x, so x I cap is this vector, and in y direction the magnitude is y and the direction is j cap, so this vector is your y j cap. Now this y j cap is parallel to this, so we can say this is also your y j cap. So from triangular law we can say that r vector, which is this, see the direction, apply the triangular law of addition, so r vector would be x I cap plus y j cap. This is your position vector, position of any particle in any moment at a xy plane. Now let us say a particle is moving in this path, in this manner, in this path, and the object, see this is a particular point. If that object move from this point to this point, let us say this point to this point, and this position vector is p and this position vector is p prime, then this position vector would be r vector and this position vector would be delta r vector. Let us say this is the, your r vector, this is r prime vector, let us say this is your r prime vector. Then see the direction, direction is in towards p and p prime. Then resultant vector would be your delta r vector, that is this, from p to p prime your resultant vector. Now see the height, see the length, see this is p, this is p prime, that means the object is displaced from p to p prime. So this is your delta x, and see the height, this is your height, this is your delta y, this is your delta y. So delta r vector, this delta r vector, apply the triangular law of addition, this delta r vector would be, r vector plus r, delta r vector would be r prime vector. So delta r vector would be your delta x I cap, because this is in x axis, and this is your y axis, so delta y j cap, this direction vector. So we can say that this is your displacement vector in a 2D plane. That means the particle moves from p to p prime, and this is your displacement vector. Now move forward to average velocity. Average velocity is rate of change of position vector or displacement vector in unit time. So delta r vector by delta t. Delta r vector is this divided by t. So delta x by t I cap, delta r by t cap. Delta x by delta t is your x component in x direction, and delta r by delta t is your y component of the particle in y direction. So this is your I cap and j cap. Now instantaneous velocity. See, if that particle, the particle moves from p to p prime in a delta t time, the particle moves from p to p prime. If we say that if we decrease the time, that means the time is very small. If the time is very small to move from p to p prime, we can apply limit. We apply limit where we have to minimize the distance, the time, or anything else. So limit delta t tends to 0 means the object which is at p prime is very nearer to p. The object which is at p prime is very nearer to p. That means you can see that here if we apply limit, the time difference is very small. That means when delta t tends to 0, that means in no time the particle is in the same position at p to p prime. That means those p and p prime are at same position. So apply limit delta t tends to 0, delta r by delta t. This is the definition of derivative delta r by delta. Limit delta t tends to 0, delta r by delta t is actually your dr by dt. So instantaneous velocity, that means at a particular instant, the instantaneous velocity is defined as dr by dt. Now what would be the direction of that velocity? Always remember, direction of velocity at a particular point in a curve is always towards the tangent. If you have a curve something like this, and if you want to find out the direction of velocity of the particle at this point, draw the tangent, you will get the direction of velocity. Now if you want to find out the direction of velocity of particle in this position, then draw the tangent, see here velocity direction is in this direction. So direction of velocity is always towards the tangent. Always remember this is a very important point. Now move forward to average acceleration. Acceleration in plane you can apply as the component x component and y component. See, in displacement vector or position vector or velocity vector, you will always have a two component, that is x component and y component. See, x component, y component, In 2D plane you will always have two components in x component, one is x component and one is y component. So that means for acceleration case you would have two components, that is x component, let us say x component of acceleration is ax and y component of acceleration is ay. Now move forward to instantaneous acceleration. Same definition from velocity. Limit delta t tends to 0, delta v by delta t is your dv by dt. So instantaneous acceleration is dv by dt. Again the same logic. See, if the particle is here, let us say if the particle is here, that is p prime and p are same point, p prime and p are very nearer or equivalent to same point, that means, see, we know that direction of velocity is always towards the tangent. So if the particle is here, then the tangent would be here, tangent. So direction of velocity is this, and direction of acceleration is perpendicular to velocity vector. Always remember, direction of acceleration is always perpendicular to velocity vector. So we can say that acceleration is normal to velocity. Because we know if two perpendiculars are given. So let us say this is a vector and this is b vector. So here we can say that b is perpendicular to a and a is perpendicular to b. If two vectors or two lines are perpendicular to each other, then one is known as perpendicular, another is known as normal. So we can say that acceleration and velocity in 2D or 3D plane is always perpendicular to each other. That is the direction of acceleration in the 2D plane. So we are moving forward to our next topic, that is projectile motion. So in this part we will learn about two things, that is the first part is in the horizontal projection. That means we are in a something height, let us say h height, and we are throwing something in the ground. We are throwing something in the ground, not in the upward direction, this is not a vertical motion, this is a horizontal motion and vertical. Horizontal and vertical both would be there. So you are throwing something, some object in this direction. So if you throw this object, so you are throwing with a horizontal velocity. Let us say we are throwing this object with a horizontal velocity u. If this is x direction, that would be also x direction. So in our x direction, the motion, the velocity of the particle is u. Let us say in time small t, the object comes from O to P point, and the coordinate of P is x comma y. And let us say in that point, in P point, the vertical motion is the horizontal motion is horizontal component of the particle of the velocity is Vx, and vertical velocity is Vy. And let us say this resultant velocity V of Vx and Vy makes angle beta with the horizontal velocity Vx. This is our overall thing, and we have taken this as x axis and this is your y axis in the negative side. So that's why this is x and this is, that height is y, x comma y. The body is under the influence of two simultaneous independent motion. This motion, uniform horizontal velocity u, as you can see, and number 2 is vertically downward accelerated motion with constant acceleration g, because in every step there will be a acceleration towards the ground or vertically downward. In every stage the acceleration is towards the ground. Now let us first find out the trajectory of the particle, in which trajectory, or trajectory means in which path the particle will move. First we will find out the horizontal distance. Always remember, in 2D plane you have to calculate the horizontal motion and vertical motion independently, and when you calculate horizontal motion, don't think about vertical motion, and when you calculate vertical motion, don't think about horizontal motion. So our horizontal distance covered in small time t, let us say that this horizontal distance is covered x, this horizontal distance is covered in time t. So x equals to velocity into time, so u into t. So from here we got t equals to x by u. Now what is the vertical distance traveled by this particle? Y, right? So y equals to ut plus half at square. Apply the equation of motion here individually, okay? Ut plus half at square. Now see, when we are calculating the vertical motion, we will not consider the initial velocity. The vertical motion, for vertical motion u should be 0, because u is in our horizontal direction. So we will not take the velocity of u, we will consider that initial velocity u is 0 for vertical motion. So 0 into t plus half, and the acceleration is towards the downward, so gt square. So we got y equals to half gt square. Now we got x equals to t equals to x by u, put t equals to x by u in this equation. So we got this g by 2 square, keep the things in one bracket, and x square. Now see, g is accelerated acceleration due to gravity, so g is constant, u initial velocity is constant, so g by 2 u square is a constant term, so we can take k in place of g by 2 u square. So ultimately we got y equals to kx square. So we know that if we got a quadratic equation in x or y, that path would be a parabolic path. That path would be a parabolic path. So our motion or our trajectory, our motion or trajectory follows a parabolic path. That's we have proved. Now time of flight. Time of flight means the time taken by the object to move from O to A. O to A. This total time is known as time of flight. Let us say that time of flight is capital T. S equals to ut, apply S equals to ut plus half at square. S, what is the vertical height? That is h. Or what is the horizontal motion? That is in vertical motion you have to take u as 0. We have already talked about this. U goes to 0. So 0 into t, in place of t write down capital T, half g capital T square. So from this we got t equals to root under 2h by g. That is our time of flight. Remember these derivations, because in the next part when we will calculate about horizontal not horizontal motion, there would be vertical and horizontal, both of the motions in one projectile. So the technique would be same. The technique we will apply the same technique we have applied here. Now what is the horizontal range? That is this path from where that has gone up to which point that has gone, that is this path, horizontal range. So horizontal range means horizontal velocity into time of flight. Horizontal velocity into time of flight. Horizontal velocity is u, time of flight is t. We have calculated t, we know u. So horizontal range is u into root under 2h by g. Now velocity of the projectile at any instant. Let us say at time t the particle is at point p, x comma y, and horizontal velocity is vx, vertical velocity is vy, and resultant velocity from parallelogram law of addition we can calculate v, and vx and vy are at 90 degrees. So root under of a square plus b square plus 2ab cos theta, cos 90 is 0. So we will get v as root under of x square plus y square, root under of vx square plus vy square. Now what is the horizontal component of vx? Vx, always remember this point is extremely important, this point is extremely important. In any point horizontal velocity never changes. In any point horizontal velocity never changes. I am repeating it again because it is very important point for solving problems. In any point horizontal velocity never changes. So Vx would be u. Now what is the vertical component? Vertical component is Vy. How to calculate? V equals to u plus at. V equals to u, apply V equals to u plus at. So you are calculating vertical motion. Again that, see this point, you have to repeat this point. For vertical motion you have to take the initial velocity as 0. So this is 0 plus gt. So you will get Vy equals to gt. Resultant velocity would be root under of vx square plus vy square. Put the values vx and vy, you will get the resultant velocity. If the velocity makes v with a horizontal component beta, then apply tan beta. If this is vy, this would be this component will also be vy, then tan beta would be vy by vx. We got vy as gt, vx we got u, so gt by u. So from here we can calculate the angle at the particle is making with horizontal direction vx, horizontal component of velocity vx, and that would be tan inverse gt by u. See, our next topic is projectile in angular projection. In angular projection, let us say we have thrown this, or we have fired this object with an initial velocity u with the horizontal with an angle of theta. Then what would be the horizontal component? This would be u cos theta, and what would be the vertical component? This would be u sin theta. Now see, let us say this particle moves from 0 O to this point P, and the coordinate of P is x comma y, x comma y, this height is y, and the velocities we have already discussed in the previous section, that velocity at any point would be towards the tangent. So the resultant velocity would be towards the tangent v. This particle will have two components, that is, one is horizontal component vx and one is vertical component vy. Take the resultant, we will get velocity at any instant. We will get velocity at any instant. Let us say this velocity, resultant velocity, makes beta angle with the horizontal component vx of the velocity vx, and let us say maximum height is here, maximum height is it at a point, and that is hm, and horizontal range is your r, this is your horizontal range r, and at the ground, when that particle strikes the ground, again let us say the horizontal component vx, vertical component is vy, Vx would be u cos theta, and let us say this the particle V makes angle theta with the horizontal theta. If this is theta, then that angle would also be theta. Then this would be u cos theta and this would be u sin theta. Now this is the path of projectile. See, first of all we have to find out the equation of trajectory of the projectile. What would be the equation? All the derivations are extremely important what is written in the board, because all the derivation would come in your exam, maybe one or two, any one or two in your exam, and you have to remember all the formulas also to solve any sums very quickly. So see, horizontal distance covered. So what would be the horizontal distance covered? Horizontal distance means horizontal velocity multiplied by time. What is the horizontal component or horizontal velocity? That is u cos theta. So u cos theta into t. So what would be the t? T would be x by u cos theta. What would be the vertical motion? Vertical motion is vertical velocity. See, vertical velocity is u sin theta. So apply s equals to ut plus half at square. What is y? U. What is u? S. S would be y. Vertical distance y. And u is initial velocity. So in vertical motion, what would be the initial velocity? U sin theta. Into t, we have calculated t already, that is x by u cos theta, minus half. What is the acceleration? Acceleration is downwards, so it would be minus, because for any downward motion we take the sign as negative, and any upward motion we take the sign as positive. Acceleration due to gravity is always downward, so a is minus c, so minus half g t square, so x square by u square cos square t. Now see, sin theta by cos theta is tan theta, and rearrange this into x square. This equation, remember this equation also, because in JEE or in NEET you need this equation to solve various types of problem that may come in NEET and JEE. So remember this formula. So we can compare this formula with this, y equals to something px minus q x square. See, again this, look at this equation. This is the format of, in the format of x square, quadratic in x. So we can say that our projectile motion in angular projection is actually parabolic. Now let us say, let us calculate the time of maximum height. Time of maximum height. That means the particle, the time the object it takes to go from position O to position A. That is the time. That is the time of maximum height. That time of maximum height. So at the highest point, at the highest point, vertical component would be 0. At this point, you have only horizontal component. Remember this. At the maximum point, you would have only horizontal component, no vertical component. So vertical velocity component of the vertical velocity is 0. So apply v equals to u plus at. What is the vertical component of v? That is 0. Horizontal component is u sin theta into g into t max. That means the time it takes to go from O to maximum height A. So Tm you will get is as u sin theta by g. Now what is the time of flight? Time of flight means the object it takes the time it takes to go from O to this point, ground. Let us say this is your B point, O to B. That is the total time of flight. First we have calculated the time of maximum height. Now we are calculating time of flight. That means total distance, total projection. Okay. So apply s equals to ut plus half at square. Now see, when the object comes from O to this position, that means object return to its original position. So s displacement, the vertical displacement would be 0. U is u sin theta. The vertical component of u is u sin theta. And let us say t is tf and half g t square, because acceleration is always downward. So you will get minus here. So I rearrange, you will get tf equals to 2u sin theta by g. What will be the maximum height of projectile? This height. You need this height, maximum height of projectile. Apply v square minus u square equals to 2as. Now see, we know that at maximum point the vertical component of velocity is 0. So final velocity is 0, u v square. You have u, that is initial velocity. What is the initial velocity here? Initial velocity is u sin theta. So you will have 0 square minus u sin theta whole square equals to 2, and acceleration is, the direction is downward, minus g, and let us say the maximum height is hm. Rearrange, you will get u square sin square theta by 2g. Remember all the formula and all the derivations are for board purpose, and all the formulas are for JEE and NEET and for board purpose also. Now what is the horizontal range? This distance, the horizontal range, that means horizontal velocity into time of flight. We have calculated time of flight 2u sin theta by g. Horizontal velocity is, what is the horizontal velocity here? Horizontal velocity is u cos theta. So u cos theta into 2u sin theta by g. So rearrange, you will get this. See, if you rearrange this, you will get 2u square by g, and keep the 2 aside, and you will get u square by g and 2 sin theta cos theta. We know from trigonometry formula 2 sin theta cos theta is sin 2 theta. So r is u square sin 2 theta by g. Now what is the maximum condition for horizontal range? Maximum condition for horizontal range means maximum condition of horizontal range when this range would be maximum. That means the particle, how much distance the particle will travel, the maximum distance, in what angle you should throw a object, so that the object will cover the maximum distance in the horizontal range. So see, this range would be maximum if sin theta is plus 1, because we know the maximum value of sin theta is plus 1. So sin 2 theta plus 1, you can calculate from here. Sin 2 theta is plus 1. So 2 theta would be sin inverse 1. Sin inverse 1 is your sin inverse 1. Sin inverse 1 means 2 theta. Sin inverse 1 means 90 degree. So that means theta is 45 degree. So see, remember this, the maximum horizontal, you will get maximum horizontal range if you throw an object with 45 degree angle. So the object will travel the maximum distance in horizontal. Two angle of projection for the same horizontal range. If you throw a object with 60 degree from the horizontal, or if you throw the object with 90 minus 60 degree, that is 30 degree, the object will cover the same distance. The object will cover the same horizontal distance. So remember this is very important. Now velocity of projectile at any instant. So velocity of projectile, as you see, v, rectangular component. So what would be the v? V is root under of vx square plus vy square. Vx square. We know vx, vertical component, that is horizontal component, that is u cos theta. We know vy, that is u sin theta. Apply here, put it here. Vy is v is equal to u minus 80, u plus 80. G is minus, so v is equal to u minus gt. Apply this, put the value here, you will get the velocity at any instant. If they want to calculate velocity at this instant, so find out the angle and resultant, you can get it from this same logic. What is the angle at that position? Let us say this is beta angle. So if this is Vy, this would be Vy also. So tan beta would be Vy by Vx. And put the value Vy and Vx here, you will get tan beta. Now see, the last topic is velocity of projectile at the end of end point. What? The velocity at this point. The velocity at this point would be same. The velocity you have thrown from origin, the velocity would be. So see, velocity of projectile at the end point, that is here, the velocity would be same because it returned to its original position, that is u. And this beta, this angle would be minus theta, because negative sign shows that projectile is moving downward. Now it came to its original position, then it is moving towards backward, that is in downward direction. That's all for projectile motion. In the next video we will solve various type of projectile motion problems and how to solve all the problems. We will solve some difficult types of problems so that you can understand projectile motion very intuitively. Thank you.